All right, let's get started. Uh, Thank you everyone for joining the webinar. The topic today is next level iceberg, maintenance catalog and spec evolution. So um, this is a follow-up to a previous webinar we had with Alex and Roy last couple of months back, I believe. And so Alex and Roy are subject matter experts in this area. So this is going to be an interesting panel. I call this a 2.5 expert because I don't consider myself an iceberg expert. So I'll lean on Alex and try to provide guidance on where Iceberg is heading and what are the best practices for the community so you can take full advantage of Iceberg. So maybe we could start with a quick round of introductions. We can start with Roy and then we can jump into our agenda later.
Yeah, sure. So again, thanks for having me. My name is Roy Hassan. I work for Microsoft, but I think most people know me from my work at Absolver and previously with AWS. Big supporter, big proponent of Iceberg. I've been working with a lot of different companies across multiple clouds to bring Iceberg-based lake houses to market, to deployment, dealing a lot with kind of the early issues that people are having with the format, the catalogs, and all that stuff that goes with it. So lots of experience in kind of hands-on building these lake houses, and looking forward to some of this deeper conversation. Alex?
Hey everybody, my name is Alex Merced. I'm the head of DevRel at Dremio. I've been with Dremio about near 4 years now, where I basically spend the majority of my time educating, entertaining, and enlightening people on the topics of things like Apache Iceberg, Apache Arrow, Apache Polaris, Nessie, just this whole lakehouse space. I got to be the co-author of Apache Iceberg, the Definitive Guide, also a co-author on the upcoming Apache Polaris Definitive Guide, and the author of Architecting an Iceberg Lakehouse, which is coming out from Manning, which Roy is actually a technical editor on, keeping me honest as I write the book. Yeah, so basically I go to sleep thinking about lake houses and I wake up thinking about lake houses. So that's me.
Thank you,
I
Alex.
don't know how you
Thank you.
actually go to
Yeah.
sleep thinking about lake houses, but
It
I wouldn't
happens.
fall asleep if that was the case.
Sure. Yeah. I can imagine following you guys on LinkedIn that you guys live, breathe, and sleep lake houses. So let me a quick introduction from my side as well. My name is Rais Pasha. I lead the product team at Rising Wave Labs. For those who are unfamiliar with Rising Wave, we are a stream processing database, sort of a hybrid category that combines the power of stream processing engine with other data model and storage capabilities of an actual relational database. So we've been around for 4 years now. Think of us like the modern alternative to Apache Flink or Spark Streaming, where you basically, if you're building streaming first unified data processing framework, then we are the solution for you. But this webinar has nothing to do with stream processing, so I want to focus exclusively on Iceberg. Before we go into the webinar, some housekeeping items. First, you must be familiar with our webinar rules earlier. Also, the attendee microphones are muted. So if you have any questions, please use the Q&A tab on your Zoom menu. We'll be recording that webinar, so the recording will be emailed to you once it's ready and edited. And then if you have any issues, I hope not, but if you have any Zoom issues, you can contact through the chat if you have a question or any technical issues you're facing. All right, let's jump right into um, the discussion. So to structure the webinar, we've tried to focus on 4 areas as the agenda. First, we have a couple of questions on Apache Iceberg V3 features, just a look back at what things have been really have resonated well with the community. And then second, we want to have a couple of questions on the compaction strategies, which is a key area that has a lot of implications on deployment, production deployments. And then catalog management, which is also can be quite confusing because there's multiple approaches. What makes sense? What are the pros and cons of different offerings in the market? And then last but not least, Iceberg V4, which is the new spec that's under review and what can the community expect in the future from to build on V3 and in terms of V4. So this is sort of the agenda we have. And then let me start first on the first topic. Maybe this is a question, and Alex and Roy, please feel free to take it as you as you chime in, because these questions are not directed at any one particular individual. These are open questions, right? What are the key improvements that were introduced in Iceberg version 3 specification, which you think have had the biggest impact in production? Yeah.
So when it comes to Iceberg V3, so just to kind of understand the nature sort of an open source project like Apache Iceberg, it's as an Apache Foundation project, there's a committee called the Project Management Committee, or the PMC. And basically what's going to happen, they're going to have to approve these things. So there was Iceberg V1, which had the basic Iceberg tables, but which were generally what's called copy and write. So you basically rewrote the files every time, even if you updated a record. Iceberg V2 kind of introduced things like merge on read and delete files and things like this. Now, Iceberg V3 introduces a lot of really cool new interesting things, such as new data types, geospatial, the variant data type, which is an improvement upon the previous JSON data type. So the idea is that with the variant, you're not just storing sort of this semi-structured data, but you're also storing metadata on it that allows you to kind of traverse that semi-structured data much quicker. So that's going to allow more, basically storing more sort of JSON-like payloads in your Iceberg tables much more efficient. There's going to be row-based lineage, and basically those are sort of like the main changes. But overall, like one of the main things that I'm pretty excited about is also the deletion vectors, just because that's going to make storing the change, basically minute row-based changes a lot more compact and quicker. But overall, like I'm pretty excited about that, and the row-based lineage. I'm interested to see how that gets implemented in actual tooling. And again, right now, since V3 just got approved, doesn't necessarily mean you can use all these features yet. Usually, you're going to expect like a 3 to 6 month lag, as all the vendors, now that they know what the official spec is, to build their implementations of the spec. But that's the beauty of a format like this, where it's community built, that these kind of things are telegraphed way ahead of time, allowing everybody to kind of make sure that they can support these things equally and really kind of provide a true ecosystem to the community.
Yeah. Yeah, I mean, Alex covered everything pretty nicely and succinctly. I think if you take a slightly step back from the technical bits that were introduced, there's kind of one main theme of V3, and that is sort of consolidating or converging the storage or the encoding of storage information between Iceberg and Delta. So one of the things that's been commonly a problem is, there are two different table formats, but the data that they're actually stored on disk, they're both Parquet, but there's differences, there's nuances between them, so they're not really compatible. So V3 consolidates that and basically makes the storage layer compatible between Delta and Iceberg. So now the main differences is really in the table format, right? The metadata, the information they stored. So it becomes a lot easier. So if a customer decides to use Databricks today to write Delta tables using V3, tomorrow they want to move to write Iceberg tables using V3 as well, data doesn't have to be rewritten, right? Before V3, it actually has to be rewritten, and there's a bunch of nuances. With V3, it's much more compatible. So I think that's one of the biggest wins in my mind for the community, is now we're kind of consolidating the storage level a layer across these formats, making them much more compatible. Now, there's still differences, right? There's still differences in the table format itself and how you access them and some of the benefits, but that's really what makes those two formats really powerful. But everything else that Alex said is right on point.
Yeah, I think the feature-wise, what I see is it's unlocking a lot of new use cases. For example, the geospatial data type, and then the functions unlock a lot of new use cases, and especially the variant new type allows for schema flexibility. That's very useful for some use cases. And then especially for high velocity data that we see with like some of the workloads that we've seen with stream processing, the deletion vectors allow, especially if you have a lot of churn in data, to be more efficient on the read side, because you have a bitmap as opposed to a full comparison you can do. And then I think the row level lineage that Alex brought up, that's also great for us, because as a CDC solution, that really helps us know what rows were changed, and how we can selectively filter out the data that we need to track. I think one other thing that I feel is full table encryption that I think is which was one of the key things missing for enterprise production deployment, especially for security minded teams. That really is another key feature that I feel. But overall, I feel like V3 was a huge step forward in terms of maturity and adoption.
Yeah, and I just want to iterate what Alex said because it's really important. Is that V3 is a spec, right? Like the spec was ratified by the community, but now the vendors have to pick it up and start supporting it. And I think especially when you look at, role lineage, you look at variant types, you look at, delete vectors, there's still a transition period from V2 to V3 because what happens in the community or in the industry right now is that most solutions, actually all solutions on the market are V2, but a lot of the solutions who just came on the market with Iceberg support just finished implementing V2, right? So for them to finish implementing V2, no customers yet using it, switching over to V3 is a bit of an undertaking. And you see this with Snowflake and Databricks and others as well, like AWS, and even us on Microsoft side. Like we all just kind of hardened V2, and now we're making fairly substantial changes to the way that we store data, even though there's a lot of benefits there. It's going to take a little bit of time. So for customers who are saying, hey, I want V3 now, probably won't happen right now, right? It'll take a little bit of time before all the engines actually implement it, test it, make sure it works, make sure the compatibility works as well as it expected to be, and then we'll be able to do it. So I think probably in the next 6 or so months, we're going to start seeing more and more tools supporting V3 properly.
And just add to that, like 100%. But like you're gonna probably see in the very short run, you'll probably be able to write V3 tables with like Apache Spark probably pretty soon. And so, but be careful, don't rush to do that, because again, then you lock yourself out of much of the other tooling, and then you kind of lose a lot of the benefits of Lakehouse. So, like Roy said, like just give a second for the ecosystem to catch up to V3.
Yeah,
got it. Yeah, so for those who are unfamiliar with how the spec and the governance works, is there like a core, like ANSI SQL has a core functionality, right? That every vendor has to have certain core functionality, and then they have extensions on top. Is there such a notion with the Iceberg PMC also, like in terms of guidance to the vendors? Or I don't know the inner workings of how.
I would say the spec is the guidance. Like once it's part of the spec, that's the okay for vendors to to implement that, because now there's a specific way to implement it. And even then, like, and that's the other thing, like, it's happened in the past that sometimes like vendors, even though they follow the spec, sometimes they may miss a piece or just slight differentiations between different languages. So again, there's always like this like little sort of transition period as people figure out exactly how to keep it consistent. But the spec is sort of the green light to go ahead.
Yeah, and then is it all of the spec, or is there like a subset of the spec that's considered core?
So I mean, there's a process, right? So V2 has been ratified by the community. Everybody sort of approved. Yes, it's ready to be released and announced, and that's V2. Now to go from V2 to V3, there's a number of features or changes that the community wants to make. Each of those changes gets reviewed, discussed, et cetera, and eventually there's an agreement on what that change needs to look like from a spec perspective, right? At the end of that, to get to V3, the community basically go one by one and say, approved to be in V3, approved to be in V3, making sure that we kind of, cross all the T's, dot all the I's, and everything is good. Once the community sort of ratifies V3, that V3 spec is for the most part closed, right? Of course, you can go back in and make changes if something is not right, but for the most part, it's closed and it's ready for the community to start building and implementing it. Before that, I wouldn't touch the V3 spec because it's very much in flux. But after that's been ratified by the community, there's a blog that goes out and the community says, all right, we ratified it, it's good to go. That's the spec. Now, together with that, after that's been sort of ratified, now the community is going back in and actually updating the reference designs. right? So there's an SDK, there are libraries, there are, connectors for other languages or other tools. Like they're starting to add those capabilities that we just ratified in the spec into those libraries, into those SDKs, and into those reference designs. So, if you decide, hey, I want to implement Iceberg today and I want to take the Rust library and I want to use it, well, it needs to support V3 features, right? So spec first, then reference implementations, and then the partners or the ISVs or the vendors out there, open source, can start implementing it on their with their own tools.
Got it. Okay, I think I'll be talking migrations from one spec to another. It's a good segue to the next question, which is schema evolution, right? Like that's something that a lot of organizations have struggled. Do you have any insight into what new tooling or patterns that you have seen as from the community as best practices to make the schema changes safer and faster?
Yeah.
Roy, you want to take that?
Alex, or you want me to?
I'll let you kick it off.
Yeah.
Like,
So generally speaking, I don't think that necessarily V3 changes a whole lot when it comes to schema evolution and schema changes. There is one feature called multi-argument transforms, where in partitioning with Iceberg, this is kind of the hidden partitions where you kind of transform a particular column and say this is a date stamp column, but I want to partition only on a year. So you pass the year function to the partition definition on this column, and it extracts only that value. So multi-argument just makes allow you to create partitions out of multiple columns. So that gives you a bit more flexibility to be able to kind of move forward or evolve forward your partitions as your system grows or as your lake grows. But besides that, I think from a schema evolution perspective, V3 doesn't change a whole lot. It makes it a bit more robust, right? Some issues have been fixed and stuff like that. But from an Iceberg perspective, it's actually one of the easier table formats to manage schema evolution. In particular, it's forward evolution, right? So be able to expand your schema by adding columns, renaming columns, partitions, adding partition columns, renaming them. When it comes to removing them, that's a bit more of a harder problem to solve, but it is supported, right? And you can also, as you do that, as you sort of say, okay, I no longer have this column, I can remove that column from the data set. You can then run background sort of async processes to compact the data, clean the data, remove those physical columns from the data without really impacting your user's ability to query that and get fresh data. So in essence, I think, Iceberg is still one of the easier platforms to handle schema evolution. But today with V3, we've added geospatial, we've added variant. So those kind of adding to the complexity. But we'll today you can add them. I don't think there's any mechanism right now to kind of like, well, I guess they're really a column, so you can rename them. Deleting them may be a challenge as you kind of use more of the features of a variant, for example. Like you can take a variant, you can splice it, right? So if you have a variant with sub columns in it, so like a nested JSON, you can potentially create partitions on those sub columns, right? On those nested fields. And that creates a bit more complexity as you try to evolve things over time. So ideally, you don't want to do that for partitions, but for accessing and filtering and querying those variants, that should be fine.
Yeah, 100% agreed. Like at the end of the day, I don't think anything really changes the way schema evolution fundamentally works in V2 from V2 to V3. And a lot of like the problems with schema evolution, which oftentimes, maybe like you're streaming in and certain events come in with a different schema than what you have in the table. The solution there is going to be more on the compute side. So it's going to be more about like the particular platform you're using and how they decide to kind of address that when it happens, more so than anything specifically in the spec, because the spec is just really going to address how the metadata is formatted or stored. And then basically sort of with some guidance on sort of like, hey, don't change this data type to this data type, but it won't necessarily decide how you should compute or handle the compute side of or handle the transactional piece. That'll be more up to like the actual query engines and tools, and to kind of figure out, okay, hey, there's an extra column in this event. What do I do? I know like in, let's say like the Kafka Connect connector, you can set it up where it'll automatically add a column and things like that. But again, that just depends on sort of the implementation.
Yeah. So one thing I would add is the governance part of it, of how you make the DDL or the schema itself as adopting a treat it as code, so you can store it along with the Iceberg snapshot, so you can basically adopt as if you're versioning the code, right? So that you can have two copies of the DDL, one that's more in the staging environment where you can experiment, and then once it's ready, so you basically have this rollback to snapshot and move forward, as Roy mentioned, that allows you to do the governance from external as if you're managing a repo, right? I think that's really de-risks a lot of the issues that you see with more traditional schema management. So let's go next to the next topic, compaction, which is a very deeply technical topic, but I thought, I know there's three strategies that are commonly discussed, bin, pack, sort, and the order. And I'm sure there are pros and cons. My layman understanding of what it is they, in terms of the cost, they bin, pack, sort, the order in that specific way are higher in cost in terms of the actual compaction cost, but they also yield more benefits in terms of query time gain and the kind of use cases they unlock. What is your take? Maybe Alex, you want to start?
Yeah,
And
I'll start with
give you a
the high level. So basically, generally, when you're doing compaction, and just kind of make sure everyone's on the same level as far as compaction goes, the issue is when you write an Iceberg table, you're not modifying old files, you're not deleting old files, you're always writing new files. So what happens over time is you start collecting lots of files. So imagine you're doing streaming ingestion, you might end up having a lot of files with only a small number, a lot of small sort of Parquet files being built up in your storage. But ideally, you're going to get much better scanning performance if that data was scanned in fewer, larger files. So with compaction, what you're doing is you're taking those smaller files and turning them into fewer, larger files. Now, what is the logic that, in this case, usually when you hear people talk about sort of constructing your own compaction strategies, we're oftentimes talking about the libraries that are for Spark, which has these procedures that allow you to it's called like rewrite data files. And you can choose your compaction strategy in that procedure, which could be bin pack, which just cares about, hey, let's just make optimally sized files. We don't care about co-locating data. So in this case, it'll just take, hey, I have like a bunch of small files. We'll just smush them into one bigger file, regardless of what specific data is in the file. And that's that. Okay, so it's going to be a little bit more straightforward because there's no additional logic about sort of, hey, what data is being located in which file. Now, when you sort, what you're doing is you're going to sort the data before you write it to the files. So you have to kind of read all the files, then sort the data based on the way you specify it, and then it'll write the data. And this will essentially cluster the data. So that way, basically, data with a similar value in those sorted columns are going to be in the same data files. Okay, and then Z order does something similar, but it's more equal weighted between multiple columns. So in this case, I could say, hey, the example I always use is, what if I have a table where the two columns that I typically search on are age and height. Okay, so I can imagine that what it'll do is that's going to equally weight the age and height. So in this case, the way it might, if I were to imagine like a 4 quadrants in a square, one quadrant might be like age 1 through 50 and height 1 to 3 foot. And then, another quadrant will be ages 1 through 50, 3 to 6 foot. And then another quadrant would be 50 to 100, age, height 3 to 6 feet, and then 50 to 100, height 3 to 6 feet. And essentially all the records will kind of be distributed into these 4 quadrants, sort of as a sort of a mental model. And then those files, basically that data will be clustered into certain files. So it allows you to kind of equally weight multiple columns. But the idea is that these other two allow you to cluster the data based on values. Catch is there's a lot more processing work because you have to now go read that data, sort that data, organize how you're going to write it to these files. But fortunately nowadays there's a lot of services that can do this for you. This clustering. So I know Dremio, we just recently announced that we offer Iceberg clustering. AWS, I think just last week announced that they are offering Iceberg clustering on their services, and I'm sure you're going to see a lot more coming up in the very near future. So being able to have this kind of taken care of for you is becoming a bigger and bigger thing.
So I guess if you have like multi-dimensional access patterns in the query, then the order would be best because you kind of know that it'll avoid full table scans or wherever because of the fact that the later data is laid out. So it almost your query access patterns should dictate what strategy you pick. Is that the right way to think about it?
100%. Well, your query access patterns, specifically if you choose to do sort in Z order, like if you don't have a particular column or multiple columns that you're running queries on, then just run bin pack. You know, and it's going to be a mix of this plus your partitioning strategy to begin with that'll kind of determine your, you know, the overall story. But I'll wrap it up there.
Yeah. So I mean, I sort of look at it in two categories, right? There's the write path and there's a read path, right? So when you're optimizing, compaction in essence is a right side optimization for the benefit of the read side, right? So it's a bit of a complicated sort of way to answer that question. To Alex's point, the way that you optimize your writes ultimately results in better reads. So you have to be able to say, you know, how is my user going to filter the data, right? That's how I'm going to partition it. How is the user going to order the data when they run a query? That's how I should think about sorting the data in advance, right? So all of these little knobs and levers that you get in the compaction process is based on how are the users ultimately going to consume the data so they can get the best performance. Now, that's on the read side. On the write side, you want to be able to write data and compact it in a way that reduces the size of the table, obviously saving you some storage. So you got to think about, you know, how big should those files be? How many row groups from a Parquet perspective should you have, right? So there's a bunch of write side sort of optimizations that you need to think about to produce the best possible sort of set of files for this table, where the partitioning is really about grouping similar data together. So when I query it, I don't have to scan the entire table. I only scan one small part of it and I get what I needed. Sorting is really helpful when you're running sort of sequential, when you're returning sequential data and you're saying, hey, you know, I want you know, data for this particular row for the last 10 days. Well, all that data needs to be sorted together. And then when that happens, I just go read a big chunk of it and I return it back, as opposed to bouncing from file to file, trying to find different chunks and then stitching it together. So long story short, you kind of need to understand the general query patterns of your users. And then you also need to understand what are some of the best practices for storing the data in an object store to be able to help the engine retrieve that data as quickly as possible, right? So with that, I think like the bin pack, sort order, Z order, like Z order is honestly like I've rarely seen it used. It's something that it's a cool idea, but like in a very, very narrow use case, it's useful. Other than that, it just causes slowdowns. Standard lexicographical ordering is great. Doing that on top of, you know, the most commonly sorted by columns, one or two, no more than that, because then the sort ordering just gets all messy. I presented about this at the Iceberg Summit, but there's a configuration in Iceberg that defines the ingested or the right sort order, so that at the table level, you define that when I write my data, I want it to be sorted on this column. I want it to be distributed in a certain way, and maybe even add partitioning. So at the table definition level, you define how data should be written into that table. So any writer that respects the table spec will be able to come in and say, the table is defined to sort on this column, partition on this column, and distribute it on, you know, basically distribute the right workload on specific column, right? So by definition, all the writers should follow the same pattern. So you're going to get consistent write performance and ultimately result in consistent read performance for your queries, right? Where today, much of that logic is defining like your Spark job, right? Or your Spark definition. Here you're defining this logic at the table level. So then any writer, not just Spark, Trino, whoever that wants to write to that table can say, oh, that's how I should write to this table. You have consistent behavior across the engine. So I think that's a really, really powerful way of handling it. Not all engines support it, unfortunately, but
Yeah.
they will in the future, I hope. But that creates this consistent behavior. So you're not getting mix and match partitioning and sorting and creating a big mess.
Yeah, this is actually a too low level of detail, to be honest. Like, I think it's a sign of maturity. Like once the engine starts supporting, so
Yeah.
the DDL itself, when you define a partitioning key or a distribution key, that should automatically take it because at a higher abstraction level. I hope that that would be the right way, because then we don't have to worry about this cost benefit analysis of each of these strategies.
Yeah,
So
and honestly, like
yeah,
when you look at some of the vendors, and we did this at Absolver, and there's a company called Rift that been doing a bunch of this automation as well for data compaction and optimizations, where they're basically looking at these query patterns. They're looking at the type of the data, the rate it's coming in, the structure of it, and are trying to figure out sort of dynamically how to adjust the write optimization as well as the async compaction process that runs after the fact. Because once you write the data, you write in a certain way, and then compaction kind of gives you the the easy out to say, okay, I may have not done a good job here, right? I'm going to fix it, right? So you can kind of balance those two. So as you write data, you're kind of learning the patterns of the data. You're learning what's the right way to write it. You're writing it optimized as best you can, but while you're doing it, you're learning, and then you can apply those learning in the background to a compaction job that comes in and kind of fixes it, right? Because you're gonna have to rewrite the files anyway when you're trying to merge them. So
yeah,
it's an opportunity for you to like, hey, maybe I sorted wrong. I'll resort here, right? Or I did bin pack to start with because it's very lightweight, but I'm going to switch to lexicographical ordering later, right?
yeah.
So you have the opportunity to come back and fix stuff.
Got it, got it. Okay, so I think the next question is also kind of related to the same, because we talked about strategies. Now we want to talk about the actual tooling, right? Like if you're a user and you have choice of, you haven't already picked a tool, there's different ways tools are offering. Some, like for example, fully managed S3 tables that they offered, which is, don't have to worry about any of this because that AWS takes care of all that.
Yeah.
What says running your own Spark jobs, what says using like open source options, like you have a Rust compactor. That's actually, we're biased to that because we are one of the contributors to that project. So there's multiple options. Maybe I know I want to make sure we are cognizant of time. If you guys can uh, specifically talk to the pros and cons and what you would say, like someone starting out, what is the best option to start with?
I mean, it depends on sort of what your sort of your engineering capacity is. So if you're someone going into Iceberg now, you have a lot more options that lower the barriers to entry. So like if it was like a year ago, then yes, you're probably going to be mostly designing your own maintenance procedures. And not only can you choose between sort of like, bin packs or whatnot, but you can get more granular with those where you can choose like, hey, I don't want to rewrite the whole table. I can rewrite portions of the table. So maybe you only rewrite a particular partition or whatnot. There's a lot of ways to optimize for it. But again, it does take a lot of time and a lot of having to sit there and understand sort of what your query patterns and whatnot. This is where like a lot of these fully managed solutions are really helpful because oftentimes they're with the tool that is running the queries. So they have even extra insight into what your query patterns are. I can speak specifically to Dremio, which is actually now called Dremio Enterprise Catalog. And technically now it's based on Apache Polaris, even though we are the developers of Nessie and co-creators of Apache Polaris. It's, basically we have that information on queries you're running at the Dremio that we can use to help better kind of run a lot of the maintenance work on your, which includes a lot of that clustering if necessary. But I mean, again, you have AWS coming up with offerings like Snowflake offers like management of their. Roy mentioned Rift, who basically has a dedicated solution to that. I think you guys have, recently released that open source project Nimtable. So there's a lot, and then I think there's another project called Apache Amoro. There's a lot of different options when it comes to sort of how you're going to manage your Iceberg tables. At the end of the day, like, there's a lot of relevant information. Like, I remember when Upsolver, you guys created that tool that kind of gave you that would basically diagnose how you should optimize your table, which was really, really cool. And so there's a lot of different options, whether they're tools to help you design your own jobs or they do the job for you. But nowadays it's a lot easier. Like, again, if you were like a medium to small company, I would definitely probably start with a managed solution, because there's already a lot of other things that are going to occupy your mind in architecting your Iceberg Lakehouse up front. Whether it's like how you're going to design your tables, how you're going to deliver your tables and govern your tables to your end users, that if you can offload that maintenance to something like a Dremio, a Rift, an AWS, that might be a better place to at least initially start. And then as you hit, if you ever determine that you do need more granular control over those maintenance, you can address that later on as you get your implementation set up. That would sort of, and then again, if you're a full-on enterprise who has like enough data engineering capacity that you can just address that right away and do a bespoke solution right away, you can do that if it makes sense. I mean, you have to kind of figure out how much money are you saving relative to the effort and what else that capacity could be used towards.
Yeah, so I'll add everything Alex said, right? But I'll add that even on the Microsoft side, now that I'm a big part of that on OneLake, there's capabilities already built into the product to be able to do all these optimizations, both for Delta tables and for Iceberg. Taking a step back, and I've been meaning to write this in a blog post, and I will soon. We're talking about a process that's very, very low level. We're talking about tinkering with the engines of your car that most people don't know how to do and probably don't really care to do, right? So yes, there are processes, there are functions inside of the Iceberg reference design and spec to make this work. But you can think of them as technical hooks, right? For engines to come in and implement them. Where the industry is kind of moving towards is automating it and injecting intelligence into that process, so it's not so much a black and white type of thing. Do I do Z order? Do I do bin pack? Do I do this? Like, it's not really that. It's really about picking and deciding the best way to solve this problem for the data set, for the query patterns of that particular data set at that particular point in time, right? So there's a lot of variations or variables that go into making the right decisions, where a user, a data engineer, would have to continuously sort of optimize and touch and change and learn and do all these things in order to keep those tables updated. Now, imagine you got to do this for 100 tables. What about 1,000, 10,000 tables, right? It just becomes completely unmanageable. So yes, you can do it in Spark. Yes, you can do it in Trino. Yes, you can do it in all these engines, but nobody in their right mind wants to write, update table, blah, 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 and like, or optimize vacuum. Like, nobody wants to do that. Yes, you can, but it doesn't mean that you need to do it. So two points about this. There's a set of products or companies right now, Rift and some of the other ones that we mentioned, Upsolver was in this camp as well, where it's an independent table management and optimization solution that kind of injects intelligence into the process. So they look at all aspects of the data, the query patterns, the catalog, everything that they possibly can to make the right intelligent optimization plan per table, right? So it's not a generic, you define whatever and they're just generically compact. They do it very intelligently per table. So the user doesn't have to do anything, right? They sort of turn it on and then the engine just figures it out, what to compact, how to order, how to partition. All those things are handled for you automatically. And it's really awesome because it works really, really well, and it goes across clouds, and it works well for all query engines. So there's that sort of bucket of companies. In parallel to that, you're seeing more of that managed storage layers being developed by the hyperscalers. So S3 Tables is a managed SaaS layer on top of S3 that allows you to sort of say, here is my Iceberg data. You do what you need to do with it and make it work for me, right? So it's a managed. So I don't need another service. I don't need to configure anything. Well, a little bit, and then it just does its thing. Now, S3 is very early on. It has some limitations, but for the most part, that's kind of the idea. On the Azure side, right, we have ADLS, which is kind of like S3, right? ADLS plus blob store. You can think of it as S3. And then on top of that, we have OneLake. And OneLake is, again, this storage SaaS service. It's a layer that includes a lot of the management of your data on your behalf. So similar to S3 tables in S3, OneLake offers a way for you to convert between Delta and Iceberg and Delta back and forth, a way to do fine-grained access controls on top of this data, and it does all the optimizations for you behind the scenes, so you don't have to worry about it. So two kind of patterns are emerging in the world. One is independent vendors are just coming in and saying, we can optimize wherever you live. And then there are hyperscaler solutions that are coming and saying, if you're inside of my environment, I'm going to create a fully managed SaaS offering that is intelligent enough to optimize your data, compact, sort, blah, 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 all that stuff. So all these conversations we're having about these optimizations are great, but they're like us talking about the engine of a car, right? Like, what carburetor do you have? What turbo do you have? Like, it's great, but most people aren't going to touch it, right? They're going to use these abstracted layers that just automatically do stuff for them.
Yeah, I think that's a very, very, very well put in terms of the two choices people have. But I think it's the expertise, as Alex said, the team has in terms of managing this. There was a question that came in right now about the cost benchmarking of each of these solutions, like assuming setting aside the operational overhead, right? What are the cost aspects? I think there have been some efforts that I've seen. I don't know if there's a standard independent benchmark per se, but there have been some data points that I've seen where 1 terabyte of data, if you were to use sort as the compaction, what would be the cost on a S3 versus S3 tables versus running it as Spark job? Are you guys familiar with any standard benchmarking, or is it just one-off exercises by people who are enthusiasts?
Yeah.
I can't speak to like a specific number. I mean, I can speak to advancements I've seen from like within Dremio solution, in a sense that like we have one fairly large organization who's been using us to manage your tables, and basically that allowed us to make a lot of improvements to our compaction writers that have really kind of that are of great value, but exactly how would I numerically put that value would be different, just because, like, again, the pricing models also between all these different solutions are very different, mostly consumption based, but sort of like what does a credit represent can be different between platforms. So it makes it kind of really hard to kind of really give a true apples comparison. My opinion would be, to the extent that you can, if you can plug in your catalog to multiple solutions and run like, maybe replicate the same table and then see what the same compaction job, how it runs across multiple platforms, to see sort of, hey, which one does it the fastest, which one does it the lowest cost, and kind of see which one kind of hits the sweet spot for you. Maybe it worthwhile explain, choose 2 or 3 possible solutions and then try it out and see how it works on your specific tables. Because a solution that works really good on a table that the vendor provides you, because it's optimized towards their engine, it's gonna be different than how it works on your workload and your specific table design. So best thing to do is really always try it on your data, just because there's so much diversity in data.
Yeah, I mean, I shared a blog post that we wrote at Absolver a while ago, so it's a little outdated, but it gives you an idea. I think, obviously, you got to test on your own, right? Your own data, your own process. The thing you got to remember is that some of these managed services, like S3 tables, for example, right? There is serverless compute behind the scenes that you don't necessarily control, right? There are certain limitations on the service, and these could be just restrictions, right? I mean, you can ask them and they may increase it for you. But there are certain sort of restrictions and limitations of how often this could run. How much compute are they going to assign to it? Because it's serverless and it's shared between lots of other tenants, you may not get all the resources. So if that's the case, if you have hundreds of terabytes of data, that compaction will probably take a long time, and will just run for a long time and could cost you a lot of money. Where other tools like Rift and some of the other ones, you can actually configure the compute and you can say, hey, I know this is a very large data set. I need to have more compute. So what we did at Absolver is that it was actually just auto scaled, right? Just like any other processing job. When we realized, hey, there's a lot of data here for us to compact, we added compute nodes, we compacted them as quickly as possible, and then we decommissioned those compute nodes. So you have some flexibility there when it comes to some of these independent compaction tools or optimization tools, where the hyperscaler ones seem to be more hands-off. So what I've seen so far, they're less tunable and configurable for you to throw more compute power at it to go faster and to do more. Now, it will probably change over time as more customers ask for this. I'm sure this will adjust and you'll have more flexibility, but they are trying to be more sort of like out of the way, like not force you to make decisions or not force you to ask questions or to configure. It just works behind the scenes. And ultimately it's going to get better and faster. And again, the pricing really depends, right? If you go to the independent ones, they're using, off-the-shelf compute. They're not serverless per se, right? So you're paying for those compute instances in your cloud environment plus their cost. And then the serverless ones, like the Snowflake one or the One Lake in Azure, like those compute costs can actually be lower because they're managed and subsidized by the hyperscaler.
Got it. Got it. Okay, so let's go to the next topic, which is the catalog management. This is again a broad topic. There's a lot of aspects.
We can spend hours here. Yeah.
Yeah. So I figured we have only 10 minutes. I figured if you could maybe touch upon, if especially for people who are coming in new, there's different three sort of families of catalogs we have, like file-based, service-based, and then REST. Right, REST is the future. We all know, but do you see any what do you see are where you could use like a service-based one or a file-based one? I guess maybe that's where we can start.
Just real, I guess, a real quick high level, like, bottom line is, like, as far as like a file-based like Hadoop catalog, no reason to use that in production really. But again, great for experimentation. If you're just dabbling in Iceberg and just want to kind of see how an Iceberg table works, great way to start. It's easy, but I highly discourage it for production. Honestly, really, there's no reason not to go to a REST-based catalog. Even like a lot of the ones mentioned over here, like AWS Glue and Snowflake, have REST interfaces nowadays, so there's no reason not to leverage those REST interfaces. And there's a huge benefit to using the REST interface in the sense that you don't have to juggle storage credentials. So in this case, there's a feature called vendor credentials. So now when you configure something like Spark, you just pass catalog credentials. You're not passing catalog and storage credentials. And this is just a more secure way of doing things, because you're not putting credentials in as many places and as many credentials, but also it creates like temporary scoped credentials per transaction, which is also a nice security feature. So really, there should be no reason to not use a REST-based catalog at this point, because there's just so many different options. And ones that aren't mentioned here are things like I want to also make sure Gravitino gets mentioned, and there's so many more coming out every day. And then Polaris, like I know like Dremio and Snowflake both have a commercial offering for Polaris, and I know about maybe 2-3 other companies and probably many more who are attaching Polaris into their products. So it's, I expect that to be sort of a very popular and very widely available offering. But another thing that's interesting as far as like file-based, of people who do want sort of a file-based offering, Jack Ma, one of the big contributors to Iceberg, recently, like he did a presentation, I think it was at the last Iceberg Summit, where he wrote a paper on a potential way of maybe doing like a REST catalog that works with a file, that does like a file-based catalog. So it'll be interesting to see how that goes in the future. And then even the possibility of updates to the REST spec that may enable something more like a Duck Lake type platform, where basically all the metadata is stored in the database. There's also different ways that the REST spec could evolve to allow a lot more permutations in the future, but you should always use that interface.
Yeah, no, I tend to agree. I think the whole conversation around, file-based catalog is nonsense. Is just, people are saying, oh my God, it's so much easier. I don't have to spin up a catalog. I'm like, okay, for local development, yes, sure. As Alex said, like when you kicking the tires and you're playing around, sure, it's easier, but nobody's ever going to go to production with it, right? And even Databricks, who are using Delta Lake, obviously, and Delta Lake can run without a catalog. when you go to a Databricks deployment with Delta Lake, it uses Unity Catalog, right? There's
Yeah.
rarely a situation where a customer does not have a Unity Catalog. It just doesn't make sense, right? So if you're playing around and kicking the tires, whatever, you can use Iceberg as a file only. You just have to know what the path is, and that's very similar to Delta as well. But spinning up a catalog on your local machine is actually very easy. Alex has a number of Docker compose files that show you exactly how to do it. It takes 5 minutes, and boom, you have an environment. So it's really, really easy to do. There's no excuse not to do it the right way, because ultimately that's how you're going to deploy this stuff into production, right? The catalog conversation always comes up though, because now we're in the lakehouse world, and the sort of perception is that the table format gives me everything I need to be able to manage lakes, and I don't need a catalog, right? So in the old data lake world, with Hadoop, we had a Hive Metastore, right? And Hive Metastore developed by the Apache Hive community, Facebook at that time, et cetera, but it never really saw a lot of innovation. Like it was small community, everybody depended on it. It's kind of like you have to do it, but you don't want to do it, but you have to do it. So now we're kind of saying like, hey, liberate ourselves from this data lake concept, and then we're asking for catalogs again, right? So people are like, wait, I thought we're not doing catalogs, but why are we doing catalogs again? There's a need for catalogs in a scalable architecture, period, right? Can we do it differently? Yes. Is it really scalable? Is it cost effective? Can we implement all the things that we want to implement in other ways? We can, but at the end of the day, you still need a catalog to really share across your organization, right? Duck Lake, came out and like, oh my God, Iceberg is so hard to do, blah, 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 blah. We're going to create our own. Okay, well, you didn't really solve any problems. You just create another version, right? It's another version of a catalog, their own version of a catalog, still talking to Parquet files. So you're not getting away from the problem. The question is where you're putting information to make it more efficient for you to retrieve and to implement certain capabilities like ACID transactions, fine-grained access controls, et cetera, et cetera. Now, the community overall is sort of settling on a REST-based catalog infrastructure, because REST-based meaning standard web service API, anybody can spin one up. You don't need to be a Java expert or a Hive expert to do. And as we've seen, there's a lot of catalogs coming to the market. There is something that we're working on, myself on the Microsoft side, plus the Snowflake guys, on bringing fine-grained access controls built on top of this catalog for any Iceberg compatible engine. So that's really, really awesome to be able to have one way of defining your policies and having it enforced by any engine that connects to the catalog. There's another work that's being handled in the community around federation. So let's say I have Unity Catalog by Databricks in one place, Polaris in another place, AWS Glue Catalog in another place, One Lake with Azure. How do I connect them together in a way that makes it feel like it's a mesh? It's like a truly connected mesh, right? If you're putting your catalog on the object store, that goes out the window, right? If you have some proprietary catalog mechanism that stores everything in the catalog, it doesn't know how to talk to other catalogs, you lose the value, right? So ultimately, we want to get to a place where an Azure customer can connect to a catalog in AWS, discover all the data sets, pick one, and then query it in place, right? Dremio comes in, they connect to different catalogs. The user just sees a bunch of data sets. They don't need to know that some of them live in One Lake, some of them live in S3. That experience is awesome, right? And then layer security on top of that. Now you have consistent enforcement of policies across all those catalogs. So ultimately, the Iceberg REST-based catalog is the way to go. We're seeing adoption across the board. Databricks, AWS, Snowflake, Salesforce, Azure, Dremio, the list can keeps going, right? That's really the future. I don't think we need to reinvent the wheel every time something feels a little bit hard. Like let's get over that. Like we can figure that out. That's more of a UX problem than a technology problem. But anyway, that's kind of my perspective on that.
100%. One thing I'd like to add is just that, like the Iceberg RESPEC, again, you should always make sure that your catalog supports that. But the RESPEC covers a very sort of like narrow world, basically like the ability to sort of read and write your tables, read and write Iceberg tables in your catalog. Now, eventually, the catalogs need to expand beyond just that, where there's referring to unstructured data, maybe other formats, things like that. And this is where I think eventually, even though we have lots of options that are REST interface, one of those options will eventually become the standard. So, I mean, and then again, mentioning how several different vendors are already productizing Apache Polaris, it seems like that's probably the direction things are going to go. And the reason why that's important is like when you think about something like a Unity catalog already has like a lot of sort of ability to bring in other things. Problem is, you want something that's the industry standard, so that way, as if I decide to use X person's catalog today, I want to be able to move over not just my Iceberg tables, but all of the stuff I have in that catalog over to another vendor. So if something becomes a standard, it really kind of, as the role of that catalog becomes greater and this capacities become wider, and you're seeing a lot of that with the federation work that Roy mentioned and the FBAC work that was mentioned as well, that you're going to want that to be sort of a very portableness. So having some sort of open source, community driven primitive, I think is eventually where things will go. So, something to keep an eye on, in the sense that there will, not only is the REST catalog the standard interface for Iceberg tables, but eventually one of these catalogs will probably become the standard one, the standard open source one.
Yeah.
And doesn't mean the other ones will disappear in the same way that, like, Delta and Hoodie haven't disappeared, and nor are they going to, but there will sort of be one that becomes sort of the default.
Yeah, I think the catalog federation that really unlocks without having to, do the conversion and keep the same copy of the data, that really helps.
Yeah.
I think we're almost out of time, and thanks, Roy, for answering questions. I was going to go to the questions, and I figured I was going to earmark 5 minutes in the end, but since you answered
I left
the question,
one of the great questions at the end there. I was going to
yeah,
ask
so
one, but I think it's a really good one for the conversation.
Yeah, just now another question came. Any suggestion how to convince the team to accept Iceberg? Currently, research scientists prefer Spark to directly write to Parquet files. So give your best pitch to convince people.
Bottom line is that basically it just takes away the pains of Parquet files. So how many times do you want to change the schema and have to write the whole data set? Or how many times do you want to go back to an older version of the same data set and you can't? Iceberg basically lets you write Parquet, but gives you all these extra superpowers that there's no reason not to use Iceberg, or at least a table format when working with Parquet.
Yeah, I echo that as well. I think, and you're talking about research scientists. I think for them, Parquet is fairly easy to work with as you pull it into other tools as well. So if you're using Spark to write, but then you're pulling that Parquet file into other tools like a data frame in Pandas or Polars or whatever, like Pandas, actually there's work to support Iceberg in Pandas right now, but Polars and some of these other tools that folks like to use already support Iceberg, and you should be able to just pull it in. So you don't need to pull in the raw files. You just connect to the table and you bring it in. And like Alex said, right, like time travel is a really powerful feature of Iceberg to say, hey, I want to look at data as it was before, this change, or a couple days ago, or something like that. So you have a lot of flexibility for the most part, because they're working with the data individually. They don't necessarily care about, commit conflicts or asset transactions or those kind of things that you would normally do in a larger lake when you have a lot of consumers. So if they're using it as their own research thing, sometimes Parquet would be okay. But if you're saying like, hey, you're writing these tables, let's write them in Iceberg so they're consumable by other people as well, I think that's really powerful. And that's something that they should think about, because you don't want to create an island where it's only your data and nobody else has access to it, or you don't have any other tools that can read it. And then the other thing that I've seen with folks that I worked with that went from Parquet to Iceberg is the optimizations, right? We talked about compaction and things like that using tools, but if you're working on a small data set, typically you end up with a bunch of Parquet files and you want to resort them and you want to, compact them. Then you have to do it inside of Spark. It's just a pain in the butt, right? You go to Spark, there's one command line, and boom, everything just works for you. So it's a really great way to optimize your data so you get better performance when you're analyzing it.
Yeah.
Yeah.
Well, I want to thank you both for taking the time. I know we're a couple of minutes over the time. I know there's some questions coming up. We'll follow up with them individually. But just want to thank Alex and Roy for again enlightening us with their wisdom on Iceberg. Thank you, guys.
Thank you.
Thank you as well.